Good afternoon, everyone. We're going to start just a few seconds late, but I know everyone is coming back from lunch and the poster session, so we're just giving people a few seconds. I hope you had good lunch, good discussions, and a lot of energy for this session. There's 6 papers. Presenters will speak one after the other, and then we'll have about 25 minutes at the end for questions. So I've got the pleasure to introduce first Michael Appleby and Chelsea Fitzgerald from Yale University Library talk about connecting AI models and users at Yale with Yale library data. Thank you.
All right, yes, we're talking about connecting users to AI models, users and AI models to Yale Library. As a bit of background, this project started in the spring when we saw that the Model Context Protocol, or MCP, was gaining traction across vendors. MCP was released by Anthropic, but in the spring, OpenAI and Google both said that they would also implement MCP support in their language models and in their tooling. What is MCP? MCP is a standardized way to connect AI models to data sources. And what we were most interested in is sort of the top elements that you see in the bottom diagram. The idea that we could take a chat client like Claude and connect it up to an external data source that had library data and could provide it back to the LLM. So where we headed was this. You see our quick search is our standard library catalog interface that we've had for years in the top left. And what we were aiming for is bringing the sort of high quality data that we have in that system into the user's context when they're using an off-the-shelf large language model in a chat environment. What you see at the bottom right is Claude Desktop interfacing with the data source containing our catalog data and some digital collections data, and agentically running multiple searches in response to a user prompt, and then providing a response and contextualizing the information that was returned from those catalog searches. What this amounts to is a sort of RAG system where Claude Desktop is the AI and the data that the vector database essentially is behind MCP and hosted on our library infrastructure. We implemented an MCP server with 2 distinct MCP tools. One of them performs a subject search or a vector search over the catalog. That's 12.5 million MARC records. And another searches our digital collections. And to build that index, we created vectors for about 150,000 IIIF manifests, extracting the metadata block and just creating a vector off of that. I won't go into the rest of the details here, but the infrastructure is really simple and not difficult to run. So at this point, I'm going to hand over to Chelsea to demonstrate the tool and talk about her user study.
Hi, good afternoon, I guess. I was going to say good morning. I'm Chelsea. I got my PhD at Yale in anthropology, and now I am a postdoc at Yale focused on library user experience research. I'm going to show a quick demo of this just so we all have a shared sense of what we're talking about and what this looks like. So if we could play the video, that would be amazing. I have inputted here into this chat interface. I am interested in the history of the New Haven Green. So with these tools, we can run a search of our digital collections and catalog, and you'll get back resources with different formats. Let's say you're interested in our digital collections and a historical map. You can go right to that item level record and click in, see that map, and that's the Green in New Haven, a historical map of it. And then if I said something like, I'm interested in more recent sources published in the last 10 or 20 years, it'll run a catalog search. And I thought this was fun. When I ran this search, I got back a hit for a documentary narrated by Paul Giamatti. So you can click that record and go right to the page where you request it. And there you go. See how you can access it if you're a student. So now I'll talk more about the research we did for this project so far. This has been a multi-method project. I'm going to talk about 2 efforts that have been involved, but we have used other methods that I won't talk too much about here. The headline is that this round of UX demonstrated proof of concept. We were trying to concept test this approach to accessing the catalog with our students and also library staff. Our main findings that I'll talk about here are that staff and students could readily prompt an AI application to employ tools to search and access Yale library data. In both groups, many said they'd prefer this approach to discovery over traditional keyword searching and feel more confident in AI outputs sourced from authoritative library data, knowing it wasn't just spitting back outputs from the web. I will talk about 2 methods we used to get feedback and input from students at different times in the past year. So because this, sorry, 2 seconds. So first, earlier in the spring, we ran an IRB-approved survey of Yale College students to see at a high level what their AI use was and what it looked like. And we also wanted to identify any reservations about use that could inform how we might think about designing with users in mind as we move forward with the project. So in this survey of students, 101 students responded. 62% said that they had used or planned to use generative AI tools for their academic work. The main reservation they cited or concern about AI use was that they were unsure where the information came from. So this is a really great point of feedback to form a hypothesis or a research problem, which was, would MCP maybe address this reservation by directly connecting users to our data, and they can see that, right, as they're looking for resources. Interestingly, the other reservations, the most frequently cited ones, were AI undermines my learning, or AI feels like plagiarism. So after we ran this survey and did testing with library staff, which I can talk about in the Q&A if that's of interest to anyone, we also embarked on a diary study, which was also IRB approved, with 10 students this fall. And the goal of that was to look at how students might use this method of accessing the catalog in their everyday lives. And also over a longer period of time in an unmoderated context. So not with us there holding hands or telling people how to use this method of accessing the catalog. I can talk more about how this was designed, but essentially we set students up with Claude, the desktop application, and they log diary entries most days for a week, a reporting period of a week using Microsoft Forms, and this helped us get basic quantitative and mainly qualitative insights about their use. So one of the main findings was that MCP boosted user confidence. This helped us test our hypothesis about whether or not they would feel more confident knowing that the outputs were coming from our data. Asking them this question, most students, 7 of 10, agreed or strongly agreed with the statement, this AI application would give me more confidence than traditional search tools like Quick Search, our primary search and discovery layer, or the Yale Online Catalog, when I need to either begin learning about a topic or find resources for my academic work. And the diary entries were important, and this is why we chose this method, because then you could follow up and ask why. So this student said, I feel more confidently about this AI application in principle because AI has ubiquitously impacted the undergraduate experience. A convenient resource like this one that connects students to genuinely meaningful, curated content might combat the seductiveness of more academically cheap AI models. But you'll also note that he shared a pain point. So it also helped us identify pain points that might help us build something better going forward. Another finding, I think I'm good on time, yeah. Another finding was that we had several students say they never used the library who participated in this study, and several at the end shared stories like this. Yale Library and Quick Search feel really far away from me. I've never used either source unless absolutely necessary, and as far as I know, my friends haven't either. Most are STEM majors. I'll just draw your attention to the bottom of this entry. The student said that this way of accessing our resources helped mesh her current thoughts with Yale Library sources catered to her, and it felt personalized. This tool helped me learn more about the library's collections as well as the vastness and variety of its collections, and now I feel like Yale Library doesn't feel too far away after all. I mean, come on, that's pretty great. I think I had one other slide, but that's okay. Probably doesn't matter. Sorry, what was that?
There's an appendix slide after the thank you.
Oh, no, it's okay. I think, so ongoing big questions. Right, I think we're in higher education, so a lot of the feedback we get from folks who are external stakeholders, like faculty, are about learning loss, about AI undermining student learning, making it too easy on their students. This is like a really common narrative you hear, right? So one student who had begun this study by saying that he was concerned about AI undermining his learning, I did a follow-up interview with him and used that diary entry as a prompt during the interview, and I said, you know, can you reflect on this concern? How do you feel having completed the study after a week? And he said, you know, he was really interested in how he had updated his views. He had said, I took classes on Zoom before it was a thing, and you know, now how used to Zoom are we all, right? This seemed like it would disconnect us in some ways, but in other ways it's really connected us. So that was the analogy, but I really like this part. He said, so with AI, as far as the easy thing goes, I would say lifting this barrier to entry to research gives you more mental bandwidth to actually do research, right? So it got him to the learning faster. He was definitely not of that opinion before we started the study. I'll wrap it up there because I think I'm at time. But thank you, and we'd be happy to answer questions afterward. Thank you.
Thank you very much. The next presenter is Yves Maurer from the National Library of Luxembourg, talking about Autocat Cataloging Assistant.
Thank you, Rossitza. I want to start with a controversial statement that a friend has told me from the cataloging department. He said that in the future, there will be no catalogers anymore who are not using AI. So we're not quite there yet, but I would like to talk about what we are doing at the National Library of Luxembourg in that regard. So we have, since 2009, digital legal deposit. That is a lot of files that have accumulated over the years that have been very studiously collected by the collections department. But unfortunately, we have never had resources to actually catalog those things. It's not a secret that there's more and more digital publishing, and we currently have a backlog of around 70,000 digital files. And we would like to make those available to our patrons, but without catalog records, we cannot make them available in the current systems. So we need to find a method to make it a bit more rational. That is why we have developed this Autocat method. So I'm talking about a very specific corpus, digital legal deposit. So we have the full text, we have the images. It's mainly PDFs. And at the top, you see the PDF that is taken apart image per image. It's sent into the system, and the system produces the Mark 21 record that I've abbreviated a slight bit because there's also a summary that we generate. I've taken that out, but here you see the kind of thing that it does for those of you who are catalogers. So how does it work? Well, we tried several approaches. The first approach we tried was using layout LM. That's a technique that was developed by Microsoft Research in 2020, so it's ancient. Basically, you are using the layout of the page to detect individual elements, and you train the model to detect this is a title usually, this is an author usually, and so on. We created a lot of ground truths together with an expert, but unfortunately the problem was that it takes a lot of time to generate that ground truth, and the more categories you add, it's like, so In the beginning, we just did title, author. That was okay-ish. Then you add subtitle. Then you add year of publication. Then you add publisher and things like this. And it becomes worse and worse. So this method was really not scalable. We had a second try, which was basically use a vision model, where we put the images into the vision model, and we asked the vision model, please tell me what the title is and what the author is and so on, in a very nicely formatted JSON, so that we would have the individual information for all the different fields, and then we would build the mark record ourselves. This worked, but the problem was that the results were not very consistent, and sometimes you would get inside, for example, the title, you would get, again, information which you also have in the subtitle, and then you had to sort of magically parse that and find out that you duplicate some information. And that's why we tried our third method, which is a bit simpler, honestly, and it works relatively well. So we're using, again, a vision model, which we fine-tune using examples from our catalog, and it directly outputs a mark record. So I don't know if who of you has already tried that. Just go to a big LLM provider and paste a title page and maybe an like an impressum page, and then say, generate me a Mark 21 record and return nothing else. That works already relatively well. And the thing is, we have, in Luxembourg, as everywhere else, we have our own cataloging standards. So we wanted to have something that is also fine-tuned to our examples and actually understands our cataloging rules a bit better. On your right side, you see that we also extract the text. We also extract other metadata fields that we need for the complete record from the text, like, for example, ISBN. For those of you who don't know what a regex is, that is a very ancient technology that's very, very simple. Yeah, there we have the problem that some publications, they have, inside of the full text, they have several thousand ISBNs because they cite a lot of things. You don't know which one is the correct one, but that's, yeah, it's difficult to solve. And we're also using ANIF, which is a great tool that everybody uses in the space of subject indexing. And then there's some magic post-processing. I always describe it that we take all the data that comes in and then we massage it a lot. So how does the fine-tuning work? For machine learning specialists, it's nothing new. You basically take a lot of examples where you have your input and your output to the machine, and you tell it, this is what it should look like. So we basically take 14 images of the PDF. It's like the first 7 and the last 7, together with the prompt, which is basically just to return a Mark 21 record, and together with a gold standard Mark 21 record. And when we started this, we were supposing that we needed 10,000 examples as gold standard, but it's not true. After about 200, 250, it wasn't showing any more improvements, so it's already quite good. We're currently using the base model, GPT-4o. That's mainly for practical reasons, because nearly for a year, it was the only multimodal model that you could fine-tune online. But we're looking into maybe using Gemini, where it's like even maybe local models. And so now, this was something that we had pretty much finished last year, and this year we did an evaluation because, yeah, we want to do that mountain of 75,000 files. So let's start small. We did 1,000, and I always call it 1,000 even though it's 973. That's because as every corpus that is not very well maintained, they contain duplicates, they contain things which weren't actually monographs and stuff like this. And the method we used was in May, we actually ran those 1,000 through our machine, and we had an expert cataloger review all the results, correct them up to the standard that they should be at, and then we did a comparison, like which fields have been not touched and which fields were actually corrected manually. So I'm going to present some of the results and extract. So we see that for the title, for example, we get nearly a 90% 100% correctness, so it's not even that there's a single character that had to be corrected. And in those 102 corrections, there are just a few where, yes, like title and subtitle were merged, or there were some which had multilingual titles, which should have been a uniform title, or things like this. Subtitle, again, is relatively good. For authors, our statistics are even better, sort of. It's like for the statement of responsibility, got nearly 95%, where most of the comments from our expert cataloger were that it generates a lot more responsibilities than a usual cataloger would generate. For example, if you have a book with some illustrations and just a few photographs, like usually you would have the author and the illustrator, but not the photographer. And yeah, this method also generates info about the photographer. Some statistics on our authority linking. That's for the person names. The green part is what we had linked automatically. The blue part is a lot of authors that do not exist in our authority file. That's something that our librarians have to work on. It's mainly because it's a corpus of very new publications, so it's like up to 2025. And that means that a lot of the people are not in our authority database yet. But it worked relatively well to automatically link. With corporate names, it was more difficult because a lot of the documents were from ministries or from organizations, which change a lot of times the name, and then, or they actually are not mentioned by name on the publication. They just have their logo on it, and then the AI method takes out the name as it's on the logo, or it's like a shortened version and something, and then we cannot automatically link it. So there's something where we both need to improve the authority database and yeah, maybe look into other ways of linking them. Where we're not good at the moment is subjects. So I'm really following with a lot of interest what other people are doing in the area. We have 2 subjects codes. The most important for us is the national bibliography. And there we are currently around 54%. Now we have a method which is at 55% correctness. That's yeah, not a lot more. But it's very important for us because this is national legal deposit. It needs to be part of the national bibliography interface, and so it needs to be classified. And that is something where we really have to work on. So what is our next step? Well, our next step is to integrate it into production. This is very schematic view of what we currently have as infrastructure. So we're using Alma by Ex Libris, Preservica by Preservica, and eLuxemburgensia is our online platform for digitized and digital content. And basically the idea is that we get a legal deposit and we do some automatically cataloging, and then we do some validation by a user on the catalog record inside Alma. That's the usual interface where they work anyways. However, we already have the link between the object in the long-term preservation system and the catalog. And thank you very much.
To the time, just about to interrupt you. So yes, we've got colleagues from the National Library of Sweden, Martin Malmsten and Viktoria Lundborg, to talk to us about Ordo, and they will touch on subject, AI-assisted subject generation, and yes, subject headings as well. Follow nicely from your
presentation. Hi everyone, I'm Victoria, I'm a librarian, and this is Martin. He's a data scientist and also the library's IT architect. And this is Ordo, and they are an agentic AI for library workflows. So Ordo is an ongoing project that we're working on right now. But before getting into the details, we would just like to highlight one of our main takeaways with working with this project, and that is, if you have thoughts about doing a serious AI project with resources, you have time to spend, and it's going to deal with existing human-made processes and standards, that's also an excellent opportunity to reevaluate and sometimes change those processes and standards. So Ordo is a big project. It deals with large library workflows and different types of descriptions and materials. But the use case here today, and when me and Martin usually work together, is subject analysis. And the reason for that is no coincidence. It's because I am responsible for the Swedish subject heading system. So we used to be a team, and I am the sole survivor. But I've heard that that is not uncommon in the library world. We don't have resources for this kind of work anymore. So yeah, that means that for the past 5 years or so, me and Martin, we have been working, nope.
Next year,
We've been working with how we can use machines or AI to do some, not better job, but do something with subject analysis. And sometimes it gets better and sometimes it gets worse. So we're going to show you about that. So yeah, now, this is a very scientifically made graph that shows Martin's and mine our relationship with existing library standards. So in 2020, we started using large language models on the large subject heading system. And basically, we tried to emulate what humans do. And the results wasn't great. It was very obvious that the large language model didn't understand the subject headings. That there's about 35,000 of them. And they're also very disparate in some areas, and the guidelines are also hard to understand for the model, and also for people, I might say. So it wasn't great, so in 2022, we just chucked all the standards out the window, and we were like, let's do something entirely different. So then we did a completely machine-generated system based on topic modeling techniques, and also based on a digitized corpus. And I really, really like this idea, just like try something new. But also it had no headings, because we were like, oh, maybe the headings are the problem. So what we had basically was a hard sell in the library world, because in the library world we're very heavy on tradition, we're very heavy on legacy metadata, and not heavy at all on already digitized material. So it didn't work. So in the last few years, we're back to headings and back to standards a little bit. Next slide, please. So this is an example from Ordo today. It's an analysis of a short text. It's basically a two-step process using two different AI abilities. The first one we call a candidate picker, and we use a sentence transformer to match the paragraph of text with already existing subject headings using semantic similarity. So the candidate picker picks 20 candidates out of the 35,000. And then we use a large language model that analyzes the text and also looks at the 20 candidates and picks like 1 to 3 of them. So what we learn from this is that basically we can make the AI perform a bit like a human, or how we want humans to perform. We can prevent it from hallucinating by being pretty strict and combining abilities. But is this what we want? Maybe not. But this is what we're doing, and we think it's okay. But as we can see, the candidates, they're not good. They're still way too detailed, or like the model gets confused. So what we need is a much more simpler subject heading system, both for machines and for humans. Sorry, this is not the end, Martin.
Okay, so I think one of the points of doing this is we talked earlier about basically runaway AI and not trusting it. So this is also a way of boxing in the AI, using our standards to sort of constrain the AI to do what we want it to do. So what's going on under the hood here is you've seen some of it already, I think. So you know this slide by now. It's there's a model in the middle that we call Ordo bot. Well, there's a bot in the middle called Ordo bot, which currently runs locally. It's a Gamma 3 model, but the point is that the model doesn't really matter. We attached this bot to our organization-wide group chat or chat. We use Rocket Chat at the National Library right now. And that gives it access, or rather people gain access to the bot by using the sort of the standard chat interface that we use, that we already use. And on the other end, it's the now very well-known MCP protocol. So the candidate picker is exposed using MCP. So in this case, I'm asking it's using the candidate picker to get candidates, and then it chooses one of them. Integrating it with the chat gives us this interesting opportunity that there's a second MCP endpoint called find human, which is when the bot gets confused or it's prompted. In this case, it's prompted. It can reach out to another human using the same chat. In this case, it's Viktoria, because she is defined as an expert in subject heading systems. And regarding earlier presentations, we see no problem whatsoever in building this AI-powered load balancer for humans. So, of course, there are many abilities that you could wrap MCP around. This is an example of using a vision transformer to extract from the structure from a colophon page, create BibFrame. We use BibFrame at the National Library. And to create a BibFrame record, which is fine, I think. I've been told it's fine. But the thing is, of course, that's one ability. It's not very interesting in itself. It kind of works. The interesting part is when you start building networks of these capabilities, because that's where the agentic AI comes in, where it can choose sort of the ability to use for these for a specific purpose or a specific question. This is also when we realized that, well, like with the subject heading system, some of these things that we have that we would like to expose as MCP that doesn't actually work that well. Like the information, the web page where standards information is, it doesn't work really well to convert to an MCP page. It maybe doesn't even work that well for humans either. I've been told. So, I mean, this is, again, a situation where something doesn't work for AI. Maybe it doesn't work for humans. Maybe we should change the thing instead. There's a problem, though. We have these, if we create these sort of large networks of abilities, we create these pipelines where we extract information from this slide is only to show complexity. You don't need to. Just to be, no, but it's easy to create this system, and what we lose is transparency. We have a very long pipeline. Decisions are being made within the pipeline, and we get a result, and we ask, okay, so why did this happen? So another way to deploy Ordo would be to, in this pipeline, let Ordo have access to the ability in the pipeline and also the logs of the pipeline, so that Ordo could create a sort of situation where you get a human in the loop when you need it, because these are pipelines with just enormous amount of data that flow through them. We can't control everything, but we could have Ordo ask a human when needed. And the other way is to have Ordo or a human ask Ordo for an audit of why did this happen, which would make it easier for, well, not easier, just make it more transparent, I guess. So the insights, the first one is obvious. We don't have that much time, so I'm just going to skip it. You can ask us about it later. I think, though, that this push and pull that we're in, we're using AI, we realize it doesn't really work. Why doesn't it work? We look at the standard, or we look at what we're doing. Maybe it doesn't work for human. This push and pull has been very valuable. And I think it would be a very big mistake not to take this sort of opportunity to reevaluate what we're doing. Not just, does the AI do what we are doing? Yes or no? And it's good if it's doing what we're doing. So we're basically trying to invite or be in the same space, the AI and us be in the same space, and we're hoping that everyone is having a good time.
So, going on to the next speaker from the National Library of Germany, Christoph Poley, will talk to us about usage of hardware resources for automatic subject cataloging and analysis and outlook for future challenges.
Yes.
Thank you so much.
Yeah, good afternoon. We're going to the server infrastructure. And I want to start with big tech companies like Alphabet and Meta. They have enormous human resources in data centers all over the world, and a data center can quickly cost several hundred million euro. Fact. And we have us, libraries, mostly for few resources, also fact. This is why I want to speak about the usage of hardware resources for automatic subject cataloging in our library. Basically, this presentation focuses on hardware we use or we will use in future in this rapidly changing and dynamically developing field. As an introduction, I want to give you some information about our library, as well as the motivation and use cases for automatic subject cataloging. The library is the Central Archival Library in Germany, and it was founded in 1913 in Leipzig. We have two locations, as you can see, one in Frankfurt and one in Leipzig as well. I'm from the second part of the library from Leipzig. The legitimation of our work is the law regarding the German National Library, so we collect all texts, images and sound recordings published in Germany or in the German language, translated from German or relating to Germany that have been issued in 1913. Okay. Yes. Next one. The following graphs gives us the main reason for automatic subject catalog in our library. Every day, almost 7,000 new online publications, I mean the blue bus, not the gray bus, find a way to our library with any uniform and controlled subject cataloging content. Obviously, we can't handle the mass of incoming publication using intellectual subject cataloging alone. Actually, we already started in 2009 to think about automatic methods. Our current system, the indexing machine, or in German, the Erschließungsmaschine, started in 2022. That bases on the well-known community toolbox ANF for predictions. Since 2021, we have an AI project that forms the research component for the seamless part of our developments. And I want to talk about shortly. Yes, the dimension of hardware basically depends on the use cases for automatic subject cataloging. In the area of automatic classification, we have got two systems in place to assign numbers of the Dewey Decimal classification. For that, we use supervised machine learning methods only. Last year, we annotated classification data to more than 1.2 million publications. That's a lot. And we also work on automatic indexing with the labels from the integrated authority file, and that forms an extreme multi-label classification problem. As you can imagine, we have more than 1.4 million possibly different labels we can assign. And for some labels like Germany or Europe, we've got a lot of training material, but the most labels, the long time, form few-shot and zero-shot labels. In order to cope with it, we work in production mode with supervised machine learning methods in combination with the lexical approach MLLM, the Maurer-like lexical method. Now we come to the hardware. And the hardware use cases completely differ from the user requirements. Of course, they depend on the use cases for automatic subject cataloging. Basically, we have to distinguish between the productive environment, the red one, of the indexing machine and the training stage. Therefore, the hardware depends on the underlying methods, I mean rule-based methods, supervised machine learning, and lexical approaches, and so on. In most cases, we use a combination or a fusion of methods that often increases the method's hardware needs. Of course, the input material still plays a role in hardware matters, for example, the size of the vocabulary and training data. The required hardware also depends on parameters like the number of requests and the estimated response time. For our indexing machine, the productive environment and training, we currently use VMware servers with multiple CPU courses without GPU, but this will change in the next weeks. Yes, and in addition, the services are bound. I can also talk about they are not so hardware greedy. For that, we have an OpenShift infrastructure, and we are happy. The third one use case is research. Since 2021, I already mentioned we have in our library an AI project to accelerate the knowledge transfer of natural language processing, data science, and machine learning methods into our organization. An underlying aspect was to find the balance between indexing quality and hardware needs. Therefore, we have taken the first steps in using GPU power to find some answers of derived questions like what dimension of hardware fits best to our infrastructure in future, and where are the borders and where are meaningful borders for on-premise hardware. And finally, we've gained first experiences in using an external provider to schedule jobs for a high-performance cluster. So, we go on, and new methods will come to us, and they already entered the door to our libraries, and they will all be much more hardware greedy than the current methods. I think this is not a news. Regarding to the NF toolbox, supervised learning will be shortly complemented by the X-transformer backend, and as a result of our AI project, the embedding-based matching enhances the lexical approach MLLM and implements an algorithm for matching subject with sentence transformer embeddings. And finally, we have to handle the well-known large language models, where we are just at the beginning of, I think, a longer journey. I come to a first summary. We have to distinguish between three different use cases: productive environment, training stage, and research, which has to cover more or less everything and more. With this slide, I want to give you an overview at a very high level of the methods in relation to the use cases and hardware resources. The specific hardware configuration is, of course, very individual. The green circles say that we don't need so much of hardware. The red circles mean that we have greedy methods, and the yellow circles are somewhere between. The table also gives an overview of where we need GPU power. It becomes necessary when we start to work with smaller decoder models, for example. Especially when we consider to use large language models, we mostly need much more hardware power. So, 3 slides left. After this rather summarized information concerning hardware performance, I would now like to switch to the conceptual level. Before I speak about the path towards hardware concept in general, it's important and necessary for me to address efficiency. A hardware we don't need is the best hardware. The impulse purchase, it's true, the impulse purchase of hardware is inefficient. We have to keep in mind that hardware sooner or later has its end of life cycle and will become electronic waste. New hardware needs a lot of, hopefully, green energy, as you can see, but every hardware usage we save means conserving resources and reducing the carbon fingerprint. This is one of the most important reasons why we work this year on methods that help ensure a careful use. I leave them out, but roughly estimated, this enabled us to achieve 30% production processing time and hardware usage almost without any additional other hardware needs. We're quite proud of that. Last but not least, I'll give you some information towards our hardware concept for automatic subject cataloging. Our library, for us, it defines no separate silo in our hardware architecture, even if the requirements are specific and largely incomparable with those of many other applications. The main question is, what size of infrastructure can I afford and serve in midterm future? Hardware requirements and costs continue to increase, and they need specialist skills from staff. It is essential and indispensable to collect and calculate parameters before acquisition. Writing such a concept is quite complex, so it's only natural to take a step-by-step approach. With the experience of our AI project and our current productive hardware solution, we decided as a first step to acquire new infrastructure, I mean 2 servers for automatic subject cataloging with modern GPU cards. This investment will serve to fulfill the requirements for the next, I think, 2 or 3 years, and then we have to improve. One server is for data management and for training, and the other one is for prediction, and we use it in our VMware infrastructure. The research infrastructure will adapt at a slight delay because it's quite cost intensive. So, last but not least, these activities are part of our midterm hardware concept, including, of course, the automatic subject cataloging. Regarding to the strategic aspect, we have to define and develop a bigger picture. That means that any hardware and cloud strategy must be an integral part of our IT and library strategy. We have to communicate and prioritize which products should be developed and operated, and which not. It is indispensable to find a balanced approach with a good cost trade-off to how we can achieve our targets best with available resources. And we must understand all our thoughts and activities as iterative processes. Below and finally, you find some indicators that form the operative part of the hardware concept that follow this strategy. We have to decide which use cases need hardware on-premise. Where are the financial and performance limits for the offered solutions? What does the hardware stack look like? In our library and as a guiding principle, we have decided that on-premise hardware is best suited for productive inferences for the next years. And we have to think about lifecycle aspects and maintenance and so on. Furthermore, we have to enter into useful, for us useful, cooperations with external organizations and hardware vendors, and they are usually, some are free, usually they are not free of charge and must be also suitable for using licensed hardware. It's licensed literature, it's a quite interesting point. And we have to talk about data sovereignty, for example, too. Last but not least, and for a second time in my short presentation, it's important to mention that we have to reduce our hardware requirements in parallel as well, and to discuss alternatives to hardware-greedy methods. There's considerable potential for optimization. That's a little bit of literature. That's all for today.
Thank you. It's a very serious topic. So next we've got Owen King from the GBH Archives and Kelley Lynch from Brandeis University, and their third colleague will join them later on stage for questions, surfacing and tracing contributors' large video collections. So let me get that one first.
Thank you. Hi, everyone. I'm Owen King from GBH Archives. I'm here with Kelley Lynch from Brandeis University and also Cariani, who directs GBH Archives. Before getting going, I want to credit also Kyungmin Rim, also from Brandeis, who's contributed to this research, and 2 colleagues who aren't here today, Yang Chen and Gabrielle Keen, who did a lot of great work for us. So this topic differs a little bit from a lot of the things at Fantastic Futures because we're focused on audiovisual archives, whereas most people here are primarily interested in text, although there are some overlaps. I'm hoping that in this presentation you'll see some opportunities that AV archives give for creating knowledge bases about individual contributors to productions, knowledge bases that show how these individuals have affected the communities in which they took part. Maybe this applies both in AV archives and more broadly. So the context for our work is the American Archive of Public Broadcasting. This is a collaboration between us, GBH, and the Library of Congress. We're coordinating a US-wide effort to preserve all of the history of public television and radio across the last 70 years. The computation. Oh, sorry. So the American Archive of Public Broadcasting preserves a lot of material. We prioritize preserving at-risk material, but many of the items we get come with very minimal metadata. Well, one thing we've recognized over the years is that in the case of television, there's a lot of metadata to be found in the productions themselves, in the scenes with text. So if you look on the screen here, you see 3 particular kinds of scenes with text that have metadata that are especially useful for us. The program slate, which has information about the production, the chyrons, or lower thirds, that tell who the individual on the screen is and things about them, and also the credit sequences, which we all know from both the beginning and ends of productions. So our thought is, when we start with minimal metadata, can we use these scenes with text in an AI-driven workflow to create much more rich metadata? Okay, so the computational context of our project is the CLAMS project. This is a project in the Lab for Linguistics and Computation at Brandeis University that's run by James Pustajovsky, who is at this conference and perhaps in the room, in the back there. KRIM, again, has done a lot of work on this platform. And so the CLAMS project develops tools for libraries and archives to enrich descriptive metadata by automatically extracting information from time-based media, and does this multimodally across text, audio, and video. So the way we've used CLAMS so far has been with this scenes with text detection. So going through a video and identifying, using computer vision, the scenes with text. If you grab the QR code here, you can play with this visual index. This is what we do with scenes with text. We create a visual index, what we call a visaid, that shows you all of the scenes with text. And this is a great thing for catalogers who otherwise would have to watch the entire video, because you can quickly see the people that played a role in it. Give everyone a second who's trying to take a QR code. Get the QR code. Okay, moving ahead. So the visual index is great. It's great for a cataloger to have at hand at cataloging time. But you still have to sit there and type the information off the visual index into the cataloging interface. Could we extract the data automatically? And so that leads us to the experiment that Kelley's going to be talking about.
Okay, so for this experiment, we are comparing traditional OCR models, so namely Tesseract and DocTR, which are models that were trained primarily on documents, white backgrounds, black text, when we're comparing those to large vision language models, which are not trained specifically for the OCR task, but are more general purpose and have shown generalizability to OCR. Okay, so our evaluation data set consists of approximately 4,000 chyrons. So these were manually transcribed and annotated. They were transcribed for like the verbatim transcription, what text is part of the chyron, but also some structured text extraction. So what's the name as it's written, what's the normalized name, so stripping off any titles and formatting it as like last name, comma, first name, and then listing any attributes. For the key information extraction task, we compared a few different pipelines consisting of traditional OCR plus some heuristics to generate the formatted names and segment the transcribed text into the name and the normalized name and attributes. And we compared that to just prompting a VLM for, what is this, what is the each of the desired keys, and also to having the VLM transcribe the the content of the chiron and then using an LLM to format that output. And we compared the performance of those different pipelines across Hawaiian and non-Hawaiian television programs and across different eras, so pre-2000 and post-2000. So in the creation of the data set, we tried to get a balanced set across time and across the different dates. So why did we choose Hawaiian chirons? So here's some examples, and you may notice some things here that might present challenges. Our initial hypothesis was that we may see issues due to a different ethnic distribution of names, so that the Hawaiian chirons would have like traditional Hawaiian names or Polynesian, Japanese names that differ from the names that we see in lower 48 chirons. And that additionally, different orthographic features might present difficulties. In Hawaiian, they use Okina and Kahako, which might not appear often in the training data for these types of models. And as we were exploring the data, we discovered that another challenge might be due to the visual complexity of these frames. So we have Hawaiian shirts with a lot of visual noise and flowers, leis that kind of create a sort of captcha-like image from these chirons. There's some formatting issues here. I don't know, this didn't happen on any other screen, but we can still see the best results were from the vision language models. So the traditional OCR models had a very high character error rate. Here, the higher numbers are worse. So we're reporting uncased character error rate, and we also capped the character error rate at 1. So we're averaging across all the instances, and if one instance has a lot of extra text, we didn't want that to outweigh and kind of manipulate the numbers. So the best results we saw were from the VLMs. We used Lava here, which had the best results. This was the 7 billion parameter version of Lava. You can't read the final row of the first table, but we used small VLM. And it had pretty comparable results to Lava, which was interesting because we used the 2.2 billion parameter model. So maybe with some more sophisticated prompting, we could get comparable results with a smaller model there. For the pipelined results, the best ones, which you cannot see here, I don't know how that happened. That was from using a pipeline of the Lava just to do transcription, and then using Llama, just an LLM, to do the formatting from the transcribed text. And here's some examples of the types of errors we saw. So in the top left, transcription errors. Here, when we see acronyms, that's a common place we would see errors because the vision language models often rely on some semantics of the text, and with acronyms, you kind of lose that. On the top right, we have additional text that is on the screen and is being correctly transcribed, but the models aren't following the instruction to ignore any text outside the chiron. The bottom left, we have some formatting issues and some capitalization issues, but the content is generally correct. And then the bottom right, this is a case where we would see a very high character error rate because the model chose to add some additional commentary. Please note, blah, 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 blah. So those are things that maybe we could avoid with some additional post-processing, but for now, these are the strategies we took. So our conclusion from those experiments was that VLMs were superior to traditional OCR. Having a multi-step process was ideal, and we haven't seen yet that Hawaiian chirons are more difficult, but we suspect that maybe with some further post-processing, as I mentioned, that maybe there could be some evidence for that.
Okay, so what can we do with these models that Kelley's just been describing to us? So again, start with the visual index and filter it down to just the persons with chirons. That'll be our target for cataloging of individuals. So we've built a new interface. It starts from the visual index, but then it expands to show you the extracted text in the second column, and then in the third column, an editor interface where you can both correct the extracted text and add structure to it. So the idea is that once you have the corrected text, you've structured text that's linked to a particular time code in a particular show. You can export this in two places. On the one hand, it goes to the archive's catalog. On the other hand, we can use it to populate a local authority file. Because most of the people who are prominent in public television are not actually in most of the wider authority files that most of us are familiar with. But because we're getting the structured information about these individuals and their attributes at cataloging time, we can build our own authority file from this data. And that allows us to do something pretty interesting with the individuals that are in the history of public broadcasting. You can take an individual and sort of do a distant viewing of the archive in a way that allows you to see how an individual appeared in community broadcasting over time. So in this case, you've got Ben Cayetano, and you can see a little bit of his career in Hawaiian politics. And not only is it good for people like political figures, it's also good for people who were prominent in public broadcasting. So this guy, Dan Boylan, was sort of a local legend in Hawaiian public broadcasting. And once you can find all of his appearances in television over the years, you can sort of trace his career. And in practice, you can do this with anybody. And since the scope of the AAPB is very large and across many different parts of the United States, in theory, we should be able to do this in a way that touches upon people that appear in multiple different locales over the years. I think that's all we got. Thank you very much, and here's some information about our work.
Okay, we've got our final speaker in this session, Elinor Hawkes from the Oxford English Dictionary, to tell us about the useful, trustworthy AI search assistant.
Hey. Sorry. Okay, well, thank you for your patience, everybody. I appreciate this is the last talk in the session, but hopefully it's a nice bookend with the Yale presentation at the beginning, because I'm also talking about using AI with search and discovery. So the tool I'll be talking about today is intending to help users on OED.com conduct advanced searches, and it's been live since January 2025. So I'll be talking about the process we took to build the assistant, so covering our decision-making process to get us there, how we understood what our users would want from it, how we built and tested it, and lastly, its launch, impact, and future roadmap. For the uninitiated, what is the OED? So it's widely considered to be the global authority on the English language, documenting the history of English from the Middle Ages to the present day. So scholars from around the world come to the OED to understand what an English word means now and what it used to mean in the past. And in digital humanities, people can use the OED's data set to track word usage over time and determine how changing semantics reflects changing society. We put a lot of research into creating the dictionary with our large team of lexicographers. They require a high threshold of evidence to be met before one can enter the dictionary, and that evidence is sourced from a variety of contemporary and historical texts. So far, we've collected nearly 4 million. I think this December will take us just over 4 million quotations as that kind of evidentiary text. And this quotations data combined with the data behind our 500,000 entries makes for a very rich resource to support textual analysis and research. But on the flip side, it is very complex and can be cumbersome to search, as I'll come on to. And just a very, very brief history of the OED and technology. Whilst the OED in its nature kind of looks to the past, as an organisation, we try and look forwards as much as we can. We're not shy of embracing new technology when it has been proven to help our editorial staff or to help our dictionary readers to do more and to do it better. So for instance, we've existed in electronic form since the mid-80s. We've been using electronic corpora since the 90s. We were one of the earliest websites, and now we are looking at ways that artificial intelligence can support both our staff and our users. So how do we know we wanted to build an AI tool, and how did we know it should be designed to assist with advanced search? So 2 years ago, we relaunched the OED.com platform, and that included a migration to a new technology stack and a complete overhaul of the site UI. We put loads of time and energy into making the entire UI, but especially advanced search, as user-friendly and intuitive as possible. As we could see from the analytics of our previous platform, that advanced search was just very underused. And there are several different data points that can be searched in the OED, not just the kind of definition content, but also etymologies, historical spellings, labels such as regional use or register, subject. And despite our best efforts in the new design, we still ended up with something that was pretty complicated. We have over a dozen different filters and thousands, tens of thousands, hundreds of thousands potential different search combinations across 3 different levels of data. And we could see that whilst the usage of OED increased dramatically once we relaunched, annoyingly, usage of advanced search remained pretty flat. And this is not surprising, given the expertise required to navigate and utilize it. So our desire to improve advanced search coincided with the boom in AI-powered services in 2023. And this prompted us to think about ways that we could safely and responsibly harness AI to solve some of our user experience problems. So at the time, the possibilities seemed endless, and we solicited ideas for new tools from across the OED staff. These ideas included things like translating entries into other languages, providing auto-generated summaries, chatbots. The sky was the limit. And we evaluated all of these potential use cases, scored them against feasibility, cost, and impact, and landed on a search assistant as the best option to take forward. So our next step was to validate that decision with our actual users. Fortunately, we were able to rely on OUP's in-house market research team here. They were already conducting research into librarian and academic attitudes to AI at that time. So this broad surveying of over 100 librarians and 2,000 researchers found that almost half of the surveyed librarians thought their patrons would value a chatbot that supported searches. And over half thought that there would be value in a publisher-provided tool on a specific resource, as long as it was included in the cost of the subscription. And the common theme across both surveys was that trust in AI was low, with concerns about hallucinations and quality. So we could be reasonably certain from that building an AI tool to support search was the right thing to do. The next step was to build a prototype and define its functionality. So we knew we wanted to make search easier and offer an alternative to the complex navigation of advanced search. So this led us towards allowing users to submit questions in a natural language, but we didn't necessarily want to get a natural language back from the tool. The research was clear that hallucinations were unwelcome, as was anything that kind of de-skilled people, particularly students. So we were pretty confident about building a tool that could perform consistently, avoided hallucinations, didn't use intellectual property, was explicit in how it worked, didn't replace kind of human intelligence, and was low cost enough to not require a separate subscription, was the right thing to do. So we built the prototype on that basis. And then once it was built, we tested it with a selection of OED.com users who were already familiar with the platform, but less familiar with advanced search. And those participants got a lot of value out of using the prototype, and they particularly appreciated seeing the model's reasoning behind its response, not only because this helped to kind of prove that the model was sort of trustworthy and that it was showing its thinking, but it also helped their own understanding of advanced search and what it could do, so that if at a later point they didn't want to use the tool, they were more confident in advanced searching anyway. So how does it work? So this is essentially a kind of fairly simple RAG-based model. It's designed to assess the question asked by the user. So in this case, I don't know if you can read it, but words relating to baseball from after 1950. It will give a page URL in response. Now, there are 3 different types of page URL that it can give. A simple search URL, which will take the user directly to kind of the word they've looked for if they've just asked about a single word. There can be an information page URL if a user has asked about the OED itself, so what is it, how is it put together, and a URL to an advanced search results page. So this latter option works because any queries or filters submitted by users of regular advanced search are reflected in that results page URL. So it should be possible for an LLM to infer which filters are required and construct a page URL to the results based on that initial query. So the user submits a query via the interface on OED.com. This is then submitted via an API to the LLM pipeline. The LLM decides what type of query it is, so which sort of page URL it needs to give back. It then constructs the URL. That is then validated to make sure that it's a proper URL. It's not going to result in a 404. And then the URL plus the model's reasoning is then returned back to the user, and that is too small for even me to read, but I think it says, I constructed an advanced search for you, here's a link, it will search for entries, it will restrict results using the following filters. So yeah, that's how it works. And this is currently the limit of what it can do. So it can't answer queries itself, it can't converse, and it can't provide anything other than an OED.com URL. That is intentional, and I'm kind of harking back to our keynote speech this morning, in that we were taking kind of deliberate baby steps here. So given the known concerns that we knew about for AI, we didn't want to build anything that could even potentially mislead users or expose our own intellectual property to any models. And we're really keen on demonstrating that the tool is trustworthy and safe to use. So there's no hallucination really involved. That plus the URL verification step. The worst case scenario is that either the tool can't answer at all, and that's usually because it's a query that can't be answered by our own advanced search anyway. Or it might construct a URL and it might not be the best possible URL that it could have constructed, but it gets you to the advanced search results page. You are then able to see the available kind of filters and facets and explore yourself. But either way, the user stays within OED and is only ever presented with valid OED content. As this was our very first kind of user-facing venture into AI, we needed to be confident that the tool would perform well in order to satisfy the high level of expectations that accompanied the OED. So, I can't move my mouse. I wanted to scroll down on here because I said all the important information as to which models we tested. There we go, it did it by itself. Nice. We need to identify the best LLM to work with. So we put together a test set of 60 questions and the page URLs that should be returned. And then we tried that test set on GPT 3.5, GPT 4o, GPT 4 Turbo, Claude 2, and Llama 2. And from that testing, we determined that the GPT models were the most successful in terms of correct answers and elapsed time. And we selected GPT 4o as the best model in terms of performance and cost. So I'm going to hope this works. Yes. You can see the version of the tool in action. So this is going to show the same set of results. This is the baseball words after 1950 query. This one on the top left is using the AI search assistant. The one on the bottom right is doing it kind of manually. So hopefully you can see as this loops through that you get to the same results but you get there a lot quicker using the AI assistant than you do the kind of manual clicking through the filters way, especially factoring in that it is me doing this, and I know where all the filters are and which ones to expand and how to do this. The typical OED.com user does not. So we launched this as a pilot in 2025, in January rather, and we kept it live as a pilot for 6 months whilst we monitored usage, feedback and running costs. In particular, we monitored the number of times that it had been opened, the number of queries submitted, and the overall score of the responses determined by a thumb up or a thumb down feedback button, and the traffic to and from and engagement with advanced search. And we also kept an eye out in our usual feedback channels in case there was any feedback there. Our expectation from the pilot was that we should see an increase in advanced search usage across the board compared to the previous period. Unfortunately, that expectation did not really come to be. At the end of our pilot, our analysis showed that the impact on advanced search was fairly minimal. The assistant was used by a pretty small number of people, and queries were very mixed in terms of style and quality. However, we did find that the tool had value in other ways, as we learned some things that we were not expecting. For example, looking at the queries submitted, we were able to tell that queries about language of origin and about quotations were the most popular. We didn't know that before. We also learned that a strong subset of users were using the tool looking for lists of interesting words and ways to improve their vocabulary and kind of learn English. We weren't aware that so many people were coming to OED for that reason. And we could also see that people were using the tool in their native language rather than English and still getting really good results, which was not behavior that we designed for, but we were happy to see nonetheless. So despite having a lower impact on our advanced search usage than we were hoping, we concluded that the assistant was still worth keeping as a platform feature and to continue to develop it to try and increase usage further, especially as the running costs are pretty low for us. So we're now making plans to refresh the UI of the tool so that it is easier to understand its purpose and to expand the capabilities of the tool so that it can return a greater variety of URLs, for example, to specific anchor points within entries or to use OED's historical thesaurus. So if you would like to try the tool for yourself, please do go to OED.com and click on the AI Search Assistant button in the top navigation. And I think that's it. So to conclude, we built a search assistant intended to help improve the search experience for users without risking some of the downsides of AI, such as hallucination and de-skilling. And as our understanding of this deepens, we're continuing to experiment, and we hope that we can develop this further to really fully unlock the research potential of the OED. So thanks very much.
I'd like to invite those speakers to the stage. Probably be a long line. I'll stand on the side.
I'll go this way.
Yes, so please. This is going to work.
Coming from both sides.
He's got it.
He's not doing a curtain.
And in the
Greater some pressures.
Ignore this, it's just in case I forget something.
So this is a very popular session. We already have some questions online, but wanted to give maybe, so there's a couple of hands up there, so, and another one. So let's start with you over there, the gentleman, second one.
Thank you. Sebastian Majstorovic. I'm an open data consultant for Luther AI. I have a question for the Brandeis GBH archive team. First of all, I love everything you're doing. This is so cool, and having like shirt color as a impeding factor is just a great anecdote as well. I was just wondering, now that you have had sort of like quite a bit of success with recognizing those gerunds, recognizing text, have you thought about combining it with other multimodal sort of techniques? So something that immediately comes to mind is now that you're able to track someone through their title and description through time, would you maybe also be open to combining it with facial recognition to say, oh, maybe there is an error here, or this isn't the person we were looking for? Do you think just that there's potential for using more multimodal techniques there? Thank you.
I can say just a little bit about this, but it will mostly be speculation and forward-looking. So as far as facial recognition goes, I mean, we've been hesitant about even trying it just because of the privacy concerns of facial recognition. Although it does seem nice because once you have the person identified in a Chiron, you have an association between the person's face and the information. And so that enables you to label all of the scenes in the entire video where that person appears, whether or not there was a Chiron there. So that's really nice for navigation within a particular item. We'd like to do that. It's on the wish list. Is it at the top of the wish list? Maybe not. But as far as other multimodal work goes, yes. So one of the great things about being able to pull information off of Chirons is it gives you an authoritative spelling of the person's name. And as those of us who worry about ASR know, one of the big challenges for ASR systems is getting the proper spelling of proper names. So when you get this signal from the Chirons, if you can feed that back into either the prompt you're giving Whisper, you can actually prompt Whisper if you're using Whisper for ASR, or in post-processing of your transcripts, that gives you the opportunity to correct your transcripts, which is a really nice way that multimodal things could work for us.
Shall we take the online question?
Yeah, so this question from Jen Volk for Michael and for Chelsea. The question on the Yale MCP project, super exciting. Is Claude simply a client on locally held data, or did they get the right to ingest any of your data into their own models?
They are using an account that we have organizationally where we have turned off the ability to use that data for training, if that's the thrust of the question.
Thank you. Sorry, more hands. The lady. Yes, you.
Hi, thank you for great presentations. Boyan Kim, University of Michigan. I have a question for the Yale Library team. So about the AI search bot that you created for the catalog, I was really impressed by the result that you got from the users, that it seems to be very positive. We are having a different experience in our library. So I would love to hear a little bit more about how your search was designed to handle two types of queries that are most often sought of by librarians, a known item search and then sort of exploratory subject search. So I wonder how that has been sort of in the design stage. And then the other question that I have is, I kind of forgot what was.
Let them answer this one first.
Yes.
Yeah, well, I'll answer part of this. Is we explicitly designated this as a subject-based search, and we told participants that we're not trying to support known item search. If you want to do that, head to the catalog.
Yeah, and then the other question that I had was, sorry, I lost the thread. I will come back.
Hi, Lily Dei. I'm from Clarivate, Alma. First of all, thank you, all of you. This was amazing. But I wanted to ask regarding the Oxford English Dictionary, the low adoption. How did the UI invite people to use it? Was it just like a button they could do, or if they got too many results, did it say refine? Like, what was the adoption strategy?
Yeah, so we launched in a pretty low-key manner in terms of how we added it to the site. So it's a button in the kind of global header for the site. So it's on every page, and it has that kind of standard AI sparkle with a label AI search assistant. But that's it. So it's a fairly kind of passive way of getting to it. We don't kind of prompt people to try it much. But that is something that I'm thinking about in the future. We should be able to do it if people are doing searches that have 0 results, for instance. Then we could kind of point to the button a bit more prominently there. Yeah.
Hello, I'm Hannes Loagy from the Royal Library of Belgium. I have a question for Yves, but first of all, in Flanders there's a project about facial recognition on videos too, so that's maybe an interesting, And for Yves, it's already interesting that you say that Mach 21, exactly asking a Mach 21 XML is better than JSON, because Neil from the Bodleian libraries told me exactly the same during the post-it, so that's already an interesting takeaway. But you say, as I saw, ISBN and language is taken from the text, not from the image. But then if you ask directly Mach XML, do you state explicitly do not give ISBN and language because you take it from somewhere else? Or do you have duplicate information?
This is where the magic massaging comes in afterwards. So we get the Mark 21 from, not as Mark XML, just as plain Mark 21 binary format back from the model. And it sometimes has an ISBN field, it sometimes has language fields, but we actually strip them away and we replace them by what we determined from the text, because that gives better results. And just to say why we're using Mark 21, it's because we see that like large models, they have scraped tons of Mark 21 from all of us. It's like, one example I have is that I was with our curator for the medieval collection down in the stacks, and he was telling me, yeah, this is a whole row of incunabula which haven't been cataloged. And I took a picture just of the title page, asked ChatGPT, give me a Mark 21 record. It pulled one off HathiTrust. And I mean, this is copy cataloging on steroids, sort of. So.
Thank you. We've got another online question, just general.
Yes, this is from Steve Barclay. A question for the panel in general. As you've tested or integrated different AI models, what major negatives or shortcomings have stood out, and how have they shaped your approach moving forwards?
Yes, in our library we use machine learning and lexical approaches, and with the benefits they all have and the disadvantages, and using large language models, we have experiences in our AI projects, and I think at the beginning of the next year we'll have a shorter presentation, or a shorter we write something that we will publish, sorry, shorter article.
Maybe a very short answer and very specific. We launched a chatbot in 23, sorry, 22 would have been early, which was based on ChatGPT 3.5. And during the development, which took 6 months, they kept moderating the base model a lot more. So it's like stuff that used to work last week doesn't work now anymore because we had no control over the base model. That was specific because nowadays you can checkpoint the models and you can use that one.
Yeah, similar actually. We've had the same experience where a new model has been introduced. We don't have a lot of control over that, and it might be a worse performance than the model we were using previously, so that's just something that we have to account for. Otherwise, I don't think we really have much bad experiences. Our concern is more that how people are just using it generally instead of coming to us as a sort of authority source. That's the thing that keeps us awake at night.
Yeah, I'll say the same about the evolution as the models are updated and change. The behavior changes in subtle ways, and also using MCP and the sort of agentic tool calling, the capabilities of different models vary in their sophistication around that. So I'd say those are two things we've seen.
Yeah, so we train our own models with the team over there, but for the agentic abilities. Swedish is a small language, so how well it performs in Swedish basically becomes what we measure.
So since we're using mostly local models, we don't really have the problem of the model changing, but one problem we do have is with like choosing a prompt and different prompts giving wildly different results, and of how to experiment with prompting like that.
I'm good, thanks.
Any more? Yes.
I have a question for Kelley and Owen. we're doing a very similar project in Denmark at the moment, but unfortunately under huge time pressure, and it's 4 million programs that we're doing similar stuff to. So I was just very curious about the prospect of identifying private people who've appeared in American public broadcasting and the problems of identifying these people in the future if you were to go into production with the full archive. Would that not be an issue?
I'm sorry, I'm not sure if I've understood the question. Are you thinking about
private people who are not sort of public television personalities, as it were?
Right. I guess we haven't been especially concerned about that just because the people that we're identifying are people that have appeared on, well, broadcast television in the first place. So I guess, I mean, this is maybe a question for Karen, but you know, if we found items where there was a person who wished not to be identified, we have policies for reviewing those and removing them from our, you know, the public-facing part of our website, of course. Does that address the?
Maybe you can continue over coffee.
Yeah, I'm
because
sorry.
we need to have a break now in order to be in time for the next session. So thank you, everyone, and please thank again our speakers, wonderful speakers.